Hello, today I am going to talk about fuzzers and how to use them to your advantage, either to maintain your code or to see the weaknesses in someone else's code. We are going to see the generalities about fuzzers, the origin, and a small biography to continue investigating. Let's start visualizing how any program works. We imagine any program as a machine where we provide an input, it processes, and it returns a result. For example, a calculator is a program. If we give it a 2, a plus, and a 3, it returns a 5. Or if we give it a 3, a plus, and a 3, it returns a 6. But a program does not have a single path to follow with any input. If you give it to the calculator a minus, a plus, or if the number that you give it is negative or positive, all the paths that follows to calculate the result that is going to return, it's different. And in terms of testing the code, it's difficult in a complex program to test all the different cases of inputs that can be supplied to it and how the program will process them. And that's when a fuzzer comes into play, which is basically generating random input in a massive way and feeding parts of code that receive inputs with them to see if any of them cause the program to fail or to exhibit any undesired behavior. Now we have classes of fuzzers. There are 3 different kinds of fuzzer. First, we have the dumb, the smart, and the mutation-based fuzzers. The dumb fuzzer refers to the simplest fuzzer form, the one that generates completely random data without any structure or awareness of what is being tested. The smart fuzzer is when they are aware of what kind of input the program is waiting for, and uses algorithms to determine which input will be the most successful. And mutation-based fuzzer is when you throw non-valid data generated with certain patterns. We also have another 3 classes of fuzzers. We have the generation-based fuzzer, the coverage-guided fuzzer, and the differential fuzzers. The generation-based fuzzer works with semi-well-formed data, that is, data valid enough to be accepted by the function or the part of the code that we're testing, but invalid enough to open new paths that might fail. Coverage-guided fuzzers are when the data learns which inputs are interesting. That is, inputs that manage to pass through code paths that haven't been covered before or that triggers an error. And a differential fuzzer, that is, when we compare 2 or more implementations of the same thing that were supplied with the same input. In this case, both implementations have to give the same result. In theory, they're doing the same thing. If any results differ from the other, that means that at least one of the implementations is wrong. Now, the workflow. First, we analyzed what we want to test, a function, a piece of code, or whatever we want. Then we gather the input in case we have an unknown fuzzer. In that case, the input doesn't matter. But we need to be aware of what the program receives. For example, if it parses PDF or if it receives images, we need to collect inputs with this format or mutations of it. Then we run the fuzzer. This changes depending on where the fuzzer was implemented. And finally, we analyze the crashes or bugs the fuzzer found. Now, an example. For this example, we're going to test the regex library from Rust. We are going to choose the libfuzzer tool. This is what the code structure looks like, where data is the input generated by the fuzzer, and we use the library to transform it. And the execution of the fuzzer would look like this. As you can see, the fuzzer runs and stops once it finds a crash. Now it found a crash and it stops. And while it's running, it gives us information about coverage, the execution, and the collection of the generated inputs. And it throws a little information about the bug it found. Now let's talk about the fuzzer origins and how the term fuzzing comes about. The term fuzz was first mentioned in the 80s by Professor Barton Miller when he was remotely logging into a Unix system in the middle of a storm. He was using a dial-up modem. When the torrential rains created some noise on the line, this caused that while he was typing the commands, the noise created competed with him and sending the commands with the noise was causing the programs he commonly used to display some errors or unusual behaviors. After this, he assigned a task to his students called the fuzz generator, where the students made a small fuzzer to generate random data and test the reliability of Unix programs. Now to finish, in case you want to continue investigating about the subject, here are some recommendations of books that deals with the subject of fuzzing. If you want to see more about fuzzers to investigate vulnerabilities or continue with cybersecurity, the book Brute Force Vulnerability Discovery or A Bug Hunter's Diary, it's recommended. Now, if you want to use the tool to increase the quality of your code or the testing of the code, I recommend Fuzzing for software security testing and quality assurance. This was just a very general introduction to fuzzers. I recommend further research and try creating simple fuzzers.